All right, welcome you guys. So we're looking at 2-3 today, functions and relations. Okay. So when we give you a set of ordered pairs, maybe something like this. Any set of ordered pairs like this is going to be called a relation. Okay. So the difference between a relation and a function is the following. Okay. What we have right here would not be considered a function because we have the x value or the input of 5 twice. It's going with 2 different y values. So this is a relation, but it is not a function. Relation, but not function, since every x is not going with only one y, is not paired with only one y. For something to be a function, every x can only be paired with one y. So to fix it, right, okay, we could have, a lot of the same points. Let's see, 2, 3, still do 5, -2, but I can't have 5 again with a different y value. So let's just say it's 4 or something. So this one, every x only shows up one time, right? Okay, I don't see any repeats. I don't see any x values going with 2 different y values. So this relation would be a function. Okay, so that's it. It's pretty easy. And maybe it's not x and y, so technically I should say for every input, there's exactly one output. Okay. All right, so let's go ahead and try a few of these, okay? Determine if the relation defines y as a function of x. Well, we can already see a problem, right? 2 is paired with 3, and 2 is paired with 4. So that means that this is not a function. So not a function, since 2 is paired with 2 different y values. All right, let's go take a look at this other one. So we want to determine if this set of ordered pairs is a relation. I don't see any repeating x values, right? 1 is only with 3, 2 is only with 3, and 3 is only with 5. Some people get weirded out because they see the 3 twice. But a function is every x can only go with one y. It never says every y can only go with one x. So you want to look at the x value and say, okay, here's 1 paired with 3. Is 1 paired with anything else? No. Here's 2 paired with 3. Do I see a 2 paired with anything else? No. Okay. So this is a function. Okay. Later on in the semester, we'll talk about one-to-one functions, and that's a little different. Okay, so this is the same thing. It's just they haven't listed these out as ordered pairs, right? Over here, we have all of the x values. Over here, we have all of the y values. And you can see that the x value of -2 only goes with one y value. 6 is only paired with one y value, and pi is only paired with one y value. So this mapping diagram does demonstrate a function, or does exhibit a function, right? Okay, so this mapping diagram does describe a function, since every x is paired, oops, I keep wanting to typo today, huh? It's paired with exactly one y value. Okay. There's another way to write a function. I mean, just by the way, this is exactly this, just written differently. -2 goes with -2. 6 goes with 6. and pi goes with pi. So we could write it that way if we wanted to. Okay. Now these are giving us an equation, not like a mapping diagram or a set of ordered pairs. Okay. So a lot of times it's hard to teach how to think about these because there's a lot of ways to think about it. But you guys might remember that this is a line from a previous math class. Remember that y equals mx plus b is a line. And I can give you the specifics of this line. The last number is the y-intercept, so I know it goes through 6. And the 2 would be the slope. So it would go, up 2 and then over 1. Okay. So from this dot, it would go up 1, up 2, over 1, and you'd have a line. And I'm not getting too specific on this. If you're like, whoa, you're going fast, Mecklenburg. The point of this isn't that you know how to graph a line. We're going to do that later. But the point is that you know it's a line, and that you know it's not a vertical line, really. Okay. So this is a line. So that means that this is going to be 1-to-1 since it passes what we call the vertical line test, which we're going to talk about in a second. We'll talk about it right now. Okay. If you have any equation with both x and y to the first power, it will be a function since it will be a line, a slanted line. Okay. This is a function since it passes the vertical line test. If you have any equation with both x and y to the first power, it will be a function. Okay. So I'm not claiming that so the vertical line test, right? The vertical line test is exactly what it says. If you draw a vertical line and you touch twice, it's not a function. But if you only touch one time, no matter where you draw a vertical line, then you're good. This thing will be a function. And I'll talk more about why that works in a second. But for right now, just accept that if the vertical line touches once, it is a function, okay? All right. And another way to think of it is when you plug in an x value, are you going to get 2 different y values? Don't see that happening, right? No matter what x value I plug in, I should only get one answer out. Okay, so I'm going to write that down. Another way to look at it, I just need to decrease the font size here, you guys, because we don't have a ton of space here, do we? So let me make this a little bit smaller so we have some room. Whoa, how did that? That's a little too small. There we go. All right, and then let's grab this guy and we'll make him 36 too. Okay, so another way to look at it is if I plug in, another way to look at it is that no matter what, or no matter which x value we plug in, we will only get one y value out. All right. And you're like, isn't that always the case? No. If I took something like this, if I plug in the x value of 4 and I try to solve this, you guys know when we square root both sides of the equation, right? That we have to put a plus or minus on our answer, right? So we would end up getting 2 y values that go with the x value of 4 that I put in. You can see I put a 4 in for the x, and what do we get for the y? 2 and -2. That would amount to 4 going with 2, and 4 also going with -2. Uh-oh, not a function, right? Okay. So sometimes you can plug a value into an equation and get 2 possible answers out. All right, so we're looking at the second one. I'm going to go visual again because, man, if you can think visually, these are quick. Okay. This is a parabola. I bet a lot of you know that from from a high school math class. And it's kind of the same idea where it's going to go through 6. Okay. And we can tell that it's an upwards facing parabola because the 2 is positive. So parabola kind of looks like a U. Okay. So just as a side note, anytime one of the variables is squared, it will be a parabola. Okay. Anytime one of the variables is squared, this is assuming that it's just there's no fractions or anything, right? It just looks like this, an equation looks like a polynomial. All right, so the question is, will this pass the vertical line test? Let me draw a couple vertical lines, make sure I'm convinced, okay? So if I draw a vertical line here, I pass, yep, I'm touching just one time. Perfect. This looks good, you guys. So this is going to pass the vertical line test. So it is a function. Oops, I didn't mean to capitalize that. Okay. This is a function. This is a function. There we go. All right, you guys. So now I do want to say that note, just because one of the variables is squared doesn't mean it'll always be a function. Okay, so if the x is being squared and not the y, the y is being squared and not the x, it's a sideways parabola. So it won't pass the vertical line test. Sorry guys, I'll fix it later. See, I have all kinds of typos and weird stuff going on. All right, let's see. Let's make this smaller. Okay. If x is being squared and not the y, it's a function. Let's do this. If the y is squared and not the x, it's a sideways parabola, so it won't pass the vertical line test. Okay. And that's kind of what I showed you a second ago, right? Remember I gave you guys this example of 4 in for the x. Look at that. The y is being squared. That's a sideways parabola, you guys. That will not pass the vertical line test because it'll touch twice. Okay. So put that little picture down here to remind you. Okay. All right. Okay, so we're looking at this. It's x to the first and it's y to the first, so it's a line. So it will pass the vertical line test. Okay. Both x and y are to the first power. It's a line, so it will pass the vertical line test. Over here, we can see that, the y is being squared and the x is not. Sideways parabola. I don't know why I went smaller font on this. I have plenty of space, you guys. I'll keep it big. Okay. Since the y is squared and the x isn't, it's a sideways parabola, so it will not pass vertical. And I mean, if you want to get technical, guys, don't worry about knowing this part. I'm just foreshadowing some stuff to come. This is going to be, let's see here, facing to the left, shifted. Oh my gosh, I don't know why I can't think, you guys. shifted to the right 7. 1, 2, let's just say 7. Just G here, 7. And it's going to be facing towards the left. Negative space this way. Okay. So you can see that if we were to draw a vertical line, we'd touch twice, right? So that is not a function. Okay. And don't worry about if you knew which way it faced, if you knew the details about it. As long as you know it's a sideways parabola of some sort, it's gonna touch twice when you draw a vertical line, right? So don't worry about the details. We're gonna learn that later, okay? I guess I should say more. So, I mean, I didn't put whether or not these are functions. So this one is a function since it passed the vertical line test. This one is not a function. All right. Now, all cubics are functions, you guys. Doesn't matter if they're sideways, straight up and down. All cubics are going to be functions. This particular one goes through 7, and it looks like a sideways one like this, I believe. Okay. So if all cubics are functions, that means if either the x or y is cubed and the other variable isn't, it's a function. Let me go into detail on that. All of these cubics have this kind of, I'll just write all the different types, right? So this is going to be the x being cubed. And if that ends up being negative, it just kind of flips it this way, but it's still like that. And then if you have the y being cubed, it just flips it on its side, you guys, like so. It's the same shape, but sideways. And then if it's negative, again, we'll go like this. And that's our particular case, okay? So these are all going to pass the vertical line test, no matter how you draw a vertical line, right? On any of them. I'm always going to touch just one time, no matter how I draw my vertical lines. So that's the good news. As soon as you see just one variable is being cubed, bam, you know it's going to be a yes. Okay. All right. So those are the shortcut tricks for those. And this is just continuing the vertical line test. Okay. So I said to you guys, I would kind of explain, you know, why the vertical line test works. So let me just really quickly do that. Okay. So let's say that I have this graph right here. You know, why do we do the vertical line test? So we say that if we draw a vertical line and it touches twice, then it's not a function, right? So here's an example of us touching twice. Well, if you write down those ordered pairs for this point right here, this is the point 4, comma 1. We went to the right 4 and up 1. If you look at this one down here, let's say that's 4. We went over 4 down 1. So this would be the ordered pair 4, negative 1. And so you can clearly see that if you have a set that has 4, 1 in it and 4, negative 1 in it, right? That you are repeating x values, that the x value of 4 is going to be paired with 2 different y values. So that makes this not a function. So a vertical line will show if you do have an x value, like you go over 4, oh, and you go up 1 and you also go down 1, hey, this thing's not a function, right? Okay, so let's go through and do these super fast. These are my fave. Bam, that's no, right? It hit twice. Not a function. Okay. This guy looks good to me. I don't see anywhere where I'm going to be touching twice. So this one is a function. This one does have an issue. Right here, we're going to hit twice because they're both closed circles, right? So this is not a function. If one had been open and one had been closed, it would have been a function, right? So let me just make a little side note here, make sure everybody knows that. Since both circles were closed, a vertical line touches twice. If one or both were open, it would have been a function. It would be a function. Okay. So it's important that you look, is this open or closed? And what I mean by that, in case some of you haven't seen like piecewise graphs and stuff, we could easily have a function that looks like this, same exact graph, but those dots were open. In that case, a vertical line coming through would not touch at all, right? Oops, probably should have made that guy a little bit larger. There we go. Okay. And applying function notation. So I know we've been conditioned that parentheses mean multiply, but this notation does not mean to multiply. When you see like a letter like F, G, and H specifically, they like to use those a lot. In calculus, we put a V for velocity or A for acceleration. But when you see this notation, it simply means take the number inside the parentheses and substitute it in. Okay, does not mean multiply. When you see this notation, it does not mean multiply. Sorry, guys, if they recycle notation. Take the value inside the parentheses and plug it in. Type of issues. I know parentheses with an E is plural and I is singular, but then I'm confused because like, when does anybody use, what would be considered singular? Because like, you can never just have one, right? You guys, like, don't you have to have the other side? So is that considered singular? And if I had two sets of parentheses, that would be plural? Or when they say parentheses with an I, is it literally just one of them? Anyhow, I'm going to go with I on this, but I might need to look that up. All right, so we're just going to take -3 and we're going to substitute it in for every single x that we see in the problem, you guys. So we're going to put it here and here. And then just do the math to the right-hand side. So remember, because of PEMDAS, the order of operations, exponents come before multiplication. So we got to do -3 times -3. So that's going to get us 9. And then over here, we can multiply these together, right? So we'll get -3 times -3 again, huh? Now we can multiply. 2 times 9 is 18. And if we add all of this up, you guys, we get 28. So that is your answer, 28. Ooh, it's ugly, but same idea, you guys. We are going to substitute in the square root of 2 for every x. So exponents first. So square root of 2 times square root of 2. Well, remember, these just cancel each other out and we just get 2, right? And 3 times root 2 is 3 root 2. So 2 times 2 is 4. And then when we combine like terms, right? 1 plus 4 is 5. There we go. So f of the square root of 2 is going to be 5 minus 3 root 2. So that's how we read that. Like if I was to read this, this would be read as f of -3. I'm going to put that in quotes so you guys know how to say it if you're like talking with somebody. F of -3. So quotes, f of -3. That's how we read that. Okay. So same exact, and you know what, you guys, let me move this down a bit and get the problem back in here because I don't remember what the function was. Ooh, okay, let me do this really fast. You know what? I'm just gonna go ahead and take it as is. On top of it. Whoa, it went behind it. Huh. Okay, if it's always gonna do it, then I cannot do that. So this instead. There's a glitch in my program here where when I take a screenshot, I'll show you guys in a second. There we go. I cannot get this thing off the screen now because the part that is X'd out is off the screen here. And even when I turn my Surface Pro like sideways, let me see if it works really quickly. Sorry, guys. Oh, it worked. Okay. Oh, where did it go? I'll take it. Let's go off my screen. Okay. Oh no. There we go. Okay, it's off. Cool. It's weird. This thing's glitchy. That didn't work the other day. Okay, so now this is kind of weird, but we're going to substitute in A for the X's. And you're probably going, well, you know, what do I do? Nothing. You're done. So that was nice. I'll take a bunch of those on the homework, right? Some people end up solving it. They like set it equal to 0 and solve it and stuff. Don't do that. Nowhere does it say to solve or anything. That's why reading those directions and understanding them is really important. Okay. All right, now this one's kind of tricky. This is our toughest one yet. We're going to substitute 3 plus z in for every x. And then we got a little bit of math we got to do, okay? All right. So 3 plus z times 3 plus z. That's what we're going to have to do because we got to do the exponents, right, first. And I'm going to go ahead and distribute this -3 in over here while we're at it. So -3 times 3 is -9. -3 times z is -3z. Okay, then meanwhile, let's do this foiling here, right? So let's see. We got 3 times 3 is 9, and 3 times z is 3z. And then we're going to do these two, z times 3 and z times z. So z times 3, 3z, and z times z, z squared. All right, and we might as well combine this -9 and +1. So we got -8 there. Okay. And I'm also going to combine the 3z's. So these guys. 3z plus 3z gets us 6z. And we'll go ahead and distribute. I'll do it below it. We'll distribute in the 2. Let's see what we get. 2 times 9 is 18. 2 times 6 is 12. I'm going to put it in descending order because I know that's how a multiple choice test would have it. And you guys do have some multiple choice tests. Okay. So the 2z squared is the highest exponent. Then I'm going to go ahead and group together 12z and -3z to get me 9z. And then we will group together the 18 and the -8, which should get us 10. Okay. And that's as simplified as this can get. Remember, don't set it equal to 0 and solve it. That is what f of 3 plus c is. All right. So we know this means, same thing, you guys. Just take the number in the parentheses and plug it in for x. So this would be read as g of 3. We're supposed to find g of 3. So where we see the x, we are going to substitute in a 3. So this is going to become 6 minus 6, which is 0. And what times itself gets you 0? Well, 0 times 0 gets you 0. So that's going to be your answer for g of 3. Now let's find g of 4. So we're going to substitute 4 in. Now on this one, I'm not sure, I can't remember what connect math makes you do. I mean, there's a couple acceptable answers. One, you just continue on with this and write it in the following way. Okay, that'd be one way. But I have a feeling, that what they want is to say 4 is not, and we'll talk more about this later, in the domain. Okay, since it's imaginary, right? Since it's not real. Okay. So maybe you could say undefined would be acceptable too. Not just acceptable, probably better. Put things like this into your calculator, it says domain error. But like I think if you just plug this whole thing into your calculator, that's what it would say, domain error. So when you're getting an imaginary out, you know that you have a domain error. So undefined is going to be the response for that. Okay. And you're going, what? This is weird. Okay. But the graph of this, it helps when you think about what the graph looks like, which we'll learn more about later. Okay. It's going to go through 3, 1, 2, 3, and it's going to go like this. This is what this graph looks like, you guys. So do you see why if somebody said to you, okay, hey, at 4, what's g of 4? There's no graph anywhere over here, right? And so nobody could give you an answer for that. So remember, this is the real number plane that we're graphing on, right? When we graph these. So when we're getting an imaginary, it does not show up at all on the Cartesian plane, right? Okay. And so you can see when you look at it through that lens, why when you plug 4 in, it's nonsense. And that instead of saying I root 2, undefined is a more appropriate answer. Okay, so I'm going to kind of like put a line through that just because I wouldn't mark you off if you gave me that at this point, right? We're going to get more knowledge and stuff as the class goes on. But this is more of the answer that we're looking for is undefined. Okay, because when we write something this way with this g of x, f of x notation, we're really thinking about its graph a lot of times, okay? All right, g of -4. So we're going to take that same equation and we're going to substitute in -4. And we're good now because a negative times a negative is a positive. 3 times 4 is 12. So now, see 2 plus 12, we have the square root of 14. Let me just make sure. Oh, it's 6 minus 2x. What am I doing, you guys? Take 2. I must be doing like an older one. 6 minus 2x. Okay. So this is going to be 6 plus 8 because a negative times a negative is a positive. Oh, how weird. It came out to be 14 anyways. Okay, we'll take it. All right, so I wrote it down right. 6 minus 2x. Yeah. Okay. And square root of 14 does not break down because there's no doubles inside of it, right? It's 2 times 7, so no doubles, so just leave it. All right, and now we're going to substitute in 2w. Remember, anything inside the parentheses gets plugged in for the x, okay? So 6 minus 2 times 2w. That's it. That's our answer. So we already learned how to find x and y intercepts in 2.1's video, right? And so we're just doing the same exact thing, you guys, okay? I do want you to look at this up here at the top that it'd be really easy to overlook this part. F of x is really y. And from now on, in calculus, trig, in this class, we will probably stop using y, or at least definitely less frequently. And we'll be using f of x in its spot. And just know that's a y. I mean, if you wanted to come in here and be like, if it helps you think better to write it like that, which it did for me at first. I remember in algebra being like, I'm going to put a y there, because I feel more comfortable with that. Then by all means do so. Okay, we got to know that f of x is y. Okay. So when I say to you something like, you know what, maybe I'll write it next to it because I don't want to write on top of it. Okay, so or. So last time we learned that if we want to find x-intercepts, we let y be 0. And if we want to find y-intercepts, we let x be 0, right? To find x-intercepts, y equals 0. To find y-intercepts, let x be 0. So that's going to be our plan of attack on these, you guys. Okay, so let's do that. All right, so let's start off by finding our x-intercepts. So we're going to go ahead and let y be 0. Now, if you're looking at this, you're going, there's no y there, Mecklenburg. Oh, yeah, there is. This guy is y, right? So we're going to put a 0 right there. Okay, so we're going to go ahead and move the 4 over. And to get rid of the squared, we're going to square root. And nobody's going to forget their plus or minus, right? So the square root of 4 is 2, but it's going to be plus or minus 2. Now you'll get marked off if you put that into Connect Math. It wants to know these as ordered pairs. So we have the ordered pair 2, 0 and -2, 0 as our x-intercepts. Find y-intercepts, let x be 0. So we're going to substitute a 0 in for all x's. 0 squared is just 0, so that part's gone. So that we get that f of 0 is -4. So we have the point 0 for the x, -4 for the y. And just to kind of let you guys know, again, foreshadowing, if you didn't know this, it seems like a big deal. But I could have gotten this from graphing really quickly. I would, -4 is where it would go through. 1, 2, 3, 4. Okay. And then it's a upwards facing parabola. This is the graph of it. Just accept it for right now if you didn't know. But you can clearly see there's the 0, -4. And here is 2, 0 and -2, 0. So this all makes a ton of sense once we see that graph. Definitely this is correct. So we're going to go through, and I'm just going to copy it. So let me just copy this thing, you guys. Wow, it will not let me select it. It's letting me select all kinds of other junk though. Huh. Guess I got to retype it. Okay. And I know I'm super repetitive, you guys, but that repetition just really ingrains it in our minds to where we remember it. Of course, we remember it right now because we're talking about it. But what's going to help us to remember it 2 weeks from now? Me just saying it over and over and over again. Okay. All right. Again, there is a y. G of x is my y. So we're going to go ahead and substitute 0 in for the left-hand side. And in this case, I'll probably move the absolute value of x over to the other side because it's a negative. If I move it over to the other side, it'll be a positive. Now, remember with absolute value equations, there's always two, or there's not always, but most of the time there's two answers, right? X equals 3 or x equals -3. Both will work. If you substitute a 3 in right here, the absolute value of 3 is 3. If you plug a -3 in there, right, the absolute value of -3 is 3. So we're going to have two x-intercepts, 3, 0 and negative 3, 0. All right, now we're going to substitute a 0 in for all x's. And so I didn't do it. Just kidding. So we're going to substitute a 0 in. The absolute value of 0 is 0. 3 take away 0 is 3. So we are going to have the y-intercept of 0 was our x and 3 was our y. And by the way, this is all absolute values are v's. This v has been shifted up 3 spaces. Well, later on we'll write it like this, so you can see that it's been shifted up 3. And it's actually going to go down because of the negative out front, down 1 over 1, down 1 over 1, down 1 over 1. That's the slope. Down 1 over 1, down 1 over 1, down 1 over 1. So here's your v. Okay, so you can see, yeah, 0, 3 is my y-intercept, and 3, 0 and negative 3, 0 is going to be our x-intercepts. So great job on that one. All right. So same deal. And again, I always get hopeful that no, it's not going to let me select it. So let me just type it. Okay, so we're going to go ahead and substitute in 0 for the y. In other words, the h of x. So we're going to put a 0 there. And this one reminds me a lot of the last one. We'll move this guy over since he's negative so that it says square root of x equals 2. Now to get rid of a square root, we raise both sides to a power equal to the index. So we have x equals 4. So 4 comma 0 would be our x-intercept. All right, now we're going to substitute 0 in for all x's. Square root of 0 is 0. 2 minus 0 is 2. So we have the ordered pair 0, 2, which is going to be our y-intercept. And the graph of this, let's see here. So it's negative square root of x plus 2. So it'd be shifted up 2, and it's a negative root x. So it would technically be going like this. And so it's going to go through 0, 2. That's the obvious one. Not so obvious one is that this ends up hitting F4 apparently, according to the results that we got. Okay, we've talked about a square root graph before and how it's half of a sideways parabola, you guys. There's the other half, right? So we just drew the bottom half of the sideways parabola. The reason we drew the bottom half and not the top half was because there's a negative out front. If that negative hadn't been out front, then we would have drawn the top half and not the bottom half. Okay, and again, foreshadowing, don't worry about that, but it's coming. Okay. Now these can be a little difficult to explain when I'm not face-to-face with you guys. It's so much easier when I'm face-to-face. So hopefully I do an okay job and it makes sense. Good. We have plenty of them to kind of, get good at. All right. So it says up here that for a function, the domain is the set of x values and the range is the set of y values. So it wants us to find the domain and it wants us to find the range. So when it says the domain, we just have to say, well, what x values are going to show up on this graph, right? So I claim that all x values from negative infinity to positive infinity are going to show up on this graph because it keeps getting wider and wider and wider. If somebody was like, oh, is 100 going to be on this graph? Okay, 100, let's say it's way over here. Yeah, it is, because this keeps getting wider and wider and wider. Somewhere off my whiteboard, if you will, right? It will eventually touch 100. Okay. So anything that keeps opening to the left and to the right forever like this, that's going to be a negative infinity to infinity. All right, let's talk y values now. So instead of looking left and right, you want to look up and down. Okay, so a couple tips. For domain, look from left to right. For range, look from bottom to top, from lowest to highest. So we want to look for the lowest, right? Well, the lowest is right here at this vertex, right at the minimum. So I have to find that number. So it looks like that number is going to be 2, right? 2, here's 1. So the lowest is 2. And there is no highest. There's arrows on this. Because there's arrows on it, that means it's just going to keep going up forever, right? So we can just say positive infinity. Now, infinities always get a parentheses. The 2 you have to think about. You have to ask yourself, is 2 on the graph? Well, 2 is on the graph, right? There's no open circle right here at 2, okay? So 2 is on the graph, which means include it. So give it a square bracket. If it was not on the graph, let's say that we had some funky parabola like this, where it was an open circle at 2. In that case, 2 would not be on the graph. 2 is not included. Okay. But in our case, 2 is included, so make sure you put a square bracket on it. Okay. So for the domain, it goes to the left forever. So we know we have a negative infinity. And it goes to the right forever. So we have positive infinity. And somebody might say, well, what about the middle? There technically is no gap in here. These guys right here at 0. So 0 is this vertical line, right? Right here. Hold on. This is 0. 0 is on the graph because of the solid dot right there. Okay. If those had both been open, like let's say this one was open and the other one's open, then 0 would be missing from the graph. So you'd have to do something like this. You'd have to say from negative infinity all the way to 0, but don't include 0. And then pick up on the other side from 0 to infinity. That is how we remove like a point from a set if we need to remove the point, okay? But in this case, 0 technically is on the graph and there's no gaps in it. And what I mean by gaps is we could have a graph where, let's say that the graph looks like this. It does this same thing. Let's say this is -2. And then let's say at 3, it picks up and does this thing, okay? That is 2 separate pieces where there's this huge gap in the middle, right? So that would have to be like a negative infinity to -2. Don't include the -2 because it's an open circle. Union, oops, square bracket because it's a solid circle from 3 to infinity, okay? So if there's any sort of gap in the middle, whether it be a huge gap like this or even just one point missing, you're going to use the union symbol to describe these 2 disjoint pieces. In the case that we have here, we can describe it in one piece because technically there is no gap in the middle, right? This was filled in, so even 0 where they meet up is there, okay? All right, now range, let's look at that one. So lowest, well, the lowest on the graph would be this guy, which it looks like is -10. And he is on the graph, so I'm going to include him. And then you'll notice the graph goes up forever. So this is going to be positive infinity. And there is no gaps. Like, you know how I could draw a gap right here and say there's no graph? Looking up and down, nowhere can I say there's no graph. Somebody might say through here, but I'll go, nah, look right here. Right here, there is graph. So there's technically no gaps at all going up and down. So it'll just be one interval notation, not 2. All right, for our domain, it goes to the left forever. So negative infinity. Where they meet up, which is at 1, one of them is solid. Okay, so that's good. That means that there's no hole there. Now it doesn't go to the right forever though, you guys. The difference between this, which is an arrow, and this is that the one with the dot stops, right? And so this is going to go to 1, 2, it looks like 3, 4. It looks like it goes all the way to 4 and it doesn't continue. If I wanted it to continue, I would have drawn an arrow on it. So it's going to stop at 4. So we're going to put 4. And since it's a closed circle, we are going to put square brackets, okay? So it's not going to be a negative infinity to infinity. I mean, it could easily have been by one little change, right? And it would have been. All right, now we're looking up and down. Now this one's weird up and down. The lowest point that I see on the graph is right here, right? And this is at 1. So we've got 1, but it's just the number 1. It's not a range of numbers. It's just 1. I mean, all of these are just 1. Okay. Then there's a gap. You guys see the gap? Right there is a gap. So anytime that we have a gap, we have to use the union symbol, right? Okay. And then we're going to do it again. So the lowest that we see here, well, that's 2. Okay, so we're going to go from 2, and it is on the graph. It's a solid circle. We're going to go from 2, and not all the way to infinity, you guys, right? Not all the way to infinity. We're going to go only up until 8. 8 is the highest that it ever gets, and we will include 8. Okay, so we've got, looking up and down, we got 1, a big gap, and then from 2 to 8. All right, it goes to the left forever. It goes to the right forever, slowly, but it will. Negative infinity to infinity. Okay. This little dot throws people off, but honestly, it doesn't do anything to this particular graph, okay? All right, so negative infinity to infinity. I don't need a union symbol because I don't have any gaps. Now let's look up and down, you guys. So instead of looking left to right, let's look up and down. What's the lowest? Well, it goes down forever, so negative infinity. What's the highest? Well, it doesn't go up forever. Let's see, it stops right here. So what is that? 1, 2, 3. It looks like it's 4. So 4 would be the highest, and it is on the graph since there's not an open circle. So we'll go ahead and put a square bracket on it. Okay. All right, I think this is our last question. It's a long one, but yeah, I believe it's our last one. Okay. All right. So this first page is just you understanding that f of x equals y. It's so important. I'm going to write it up here. Because what that means is anytime that you see a number inside parentheses, like on these, those are going to be x's because it's the x that's inside the parentheses, right? Okay. Whereas when you look at these other two, the next two problems, these have to be y values because they are not inside the parentheses, right? F of x equals y, so that must be y. And that's important because that's how we're going to read our graph. So let's go to A. What A is saying is that x is -3. So if x is -3, 1, 2, 3, here's -3. I'm going to find the y value. So let's count down. Let's see, 1, 2, 3. We went down 3, you guys. So it looks like it's going to be -3 for the y value. Let's go to the next one, B. So x is 0 again. So that means that we're right here at the origin. Let's find the y value. 1, 2. Looks like we went up 2 to get to that spot. So it's going to be 2 for the y value. So they gave you the x. It's your job to find the y. Now we're going to do the opposite of that. They're giving me the y. It's my job to find the x. So y is -1. Well, here's where y equals -1. So I'm there. Let me find the x value. Well, if I go over here to this dot, I went to the left one. The x value there is -1. So that's going to be our answer. X equals -1. Okay. The next one gives us a y value of 1. So we're going to come up here to the y value of 1. Now I'm not going to count over to this dot, and that's because it's an open circle, which means that the dot isn't there. So I'm going to count the other way. 1, 2. It looks like I have an x value of 2 right here at this dot, you guys. So x equals 2. Okay. So to recap on this page, the first two were giving us the x's. So -3. Our job was to spit out the y. So -3, -3. 0, 2, which is where this dot is, right? 0, 2. So they gave us the x's. We had to spit out the y's. On these other ones, they gave us the y value right here at this dot. We had to give the x. They gave me the y value here. We had to give out the x. Okay. All right. Let's go to the next slide. Same picture. Determine the x-intercepts. Well, here's the x-axis right here. I don't see it ever touching the x-axis. So determine the x-intercept. For the y-intercept, it's right here that it touches the y-axis. So that ordered pair would be 0, 2. Great, more practice on domain and range, okay? So remember, for domain, what's furthest to the left? Well, it keeps going to the left forever. So negative infinity. There's no gaps in between, right? Where this one ends, the other one picks up. So there's no gaps. So, and then it goes to the right forever, you guys. So negative infinity to positive infinity. I don't have this situation of a gap where I could go like this and say, look at this big hole in the middle. Okay, don't have that. So it's not going to be a union. All right, determine the range. So let's go lowest to highest. Now I have a gap, you guys. Check out this massive gap going up and down. So there is going to be a union symbol. All right, let's talk about this piece first. The lowest, it goes down forever. So it's going to be negative infinity for the lowest. And it only goes up here to this dot, which is at -1. Include the -1 because it's a solid dot. Then we pick up right here at +1. So right here, there is a dot, by the way, you guys. I know right here it's open, so you might be tempted to put a parentheses. But while that one's open, this over here is not open. So is 1 on the graph? Yes, the y value of 1 is on the graph. So we need to include the y value of 1. Then we go up forever all the way to positive infinity. And these get better the more you do. Okay, I promise. All right, you guys, that concludes 2-3, our section on functions. Lots of different things to think about with functions. Good luck on the homework. Take care.